And welcome back. So in this video, what are we going to add next? Let's see. Okay, so we have a picture. Well, no, it is interactive, so it's kind of almost a game. But I think what I want to focus on next is getting this ball to move. So I think what we'll do first is let's get the ball moving and just kind of bouncing off like the sides. And then we'll kind of change that in the future to actually make it bounce off the paddles. I think it might just be easier to kind of see if it bounces off the pad, like this whole space, and then change it after we understand how it's working. Alright. So what I'm actually going to do, and this is the thinking I had, but I'm going to say ball dot dx is equal to 2. This I kind of borrowed from physics, and a lot of games have physics in them. So this is going to be a little advanced, but it shouldn't be hard to understand. I'm going to name this game physics. So dx stands for, well, it stands for something called delta x, but it really just means the change in the x. This means that my ball is going to go 2 pixels every time the game like refreshes. And games sometimes run at like 60 frames per second, like movies. So like it's almost like it will make the ball keep on going to the right at like a speed of 2. So ball.dx is really just like your right and left speed. If I made it negative, it would go left. Positive makes it go right. In fact, I'm going to do ball.dy. That's how fast my y changes by. And just because I said it, let me make it like -2. That means that my ball is going to go straight down at a speed of -2 and also right at a speed of 2. So it should kind of go diagonal. We'll come back to this though. This is just me thinking ahead, because I think I'm going to use those variables. Let's see. And you want your ball code to go into your main loop. So notice how I already kind of made a comment here. And notice how it's inside the loop. It's properly indented. It's not over here. It's indented. It's part of the loop. So my loop will update the screen, figure out where the ball is, then redraw it constantly and constantly. Alrighty, so let me see. Okay, so how about I take my ball and I make its new x position equal to where it currently is. So to get where it's currently at, I'm going to have to, let me actually type this outside so we can see it better, and then I'll put it in. So ball.set is going to kind of put my ball in a new place. We saw that when we were making our paddles move. What I want to do is I want to see where the ball currently is. So let's say ball dot x coordinate. This means that it will find where my ball is, left or right, and it will just give me that number. And then I want to add to that ball dot the speed it travels. So if it's at 0, it will then add that 2. If that's 10, it will add 2. Let's see what this looks like. Let me save it and run it. Oh no, it happened so fast you can't even see it. Here, let me make it like really, really slow. Instead of 2, let me make it 0.02. That might be too slow. Or maybe it'll be just slow enough. Alright, not bad. So what this code does is forever and ever, it constantly updates the screen. At 1 second, the ball might be at 0, then it adds 2. So now it's at 2, then it adds 2. Now it's at 4. oh, actually it's adding 0.02. So that's 0, then it's at 0.02, then it's at 0.04, and it keeps updating every time it runs through that loop. So by making dx 0.02, I make it go that fast. I had it at 2, and it went so fast you didn't even see it off the screen. Okay, well, that's fun. And let me also make it go down as well. Kind of similar code, so I'm going to copy and paste it. Oh, I just copied, I pasted right over it. So I want to take the ball, and I want to set not its X, but its Y position. Every time the game kind of like goes a new frame, I want it to find out where it currently is in the Y coordinate, and then wherever it is, just add whatever the speed is, so it goes that much further each round of the loop. I'm sorry, this would be dy. So that's what our code looks like. And I remember my dy, I made like -2, so it's going to be way too fast. We're going to make it rebound in a second, so then we won't have to worry about the speed. But let us see what it looks like. Hit run. So it started at 0, 0. Then as the loop went on, it added 0.02 to make it go to the right, and subtracted or added a negative number, 0.02. So that's what's making it go diagonal. So if we're pretending we are the loop itself, this loop goes on forever. Update the screen. Okay. So take where the ball is, and then make it go a little further in the X, and make it go a little further in the Y. And this is how far it goes. We get to pick that. We did that up there. But every time this loop runs and runs and runs, it finds where the ball is, moves it a little. Finds where it is, moves it a little. That's how animations are made. Game animations, and even like any kind of animations made on computers. It's just like every second you're updating a little bit where it's moving towards. And I think what I'm going to do, I hope this is not getting too long, but well, I'm going to stop this first. If we let this run, it kind of just goes on for, well, it kind of goes on forever, and it goes off the screen and we can't see it anymore. So I'm going to add something called border checking. And a lot of games have border checking. We're doing very basic border checking. But games that keep you from falling out of like the game environment, game programmers will call that border checking. Okay, so we're going to say if the ball's x coordinate is greater than 390, and the reason I'm doing 390 is, remember, we have a width of 800, which means that we go from -400 all the way to 400 in our game screen. So if it gets to 390, it will just be right before it goes off the screen. It's right before here. If it goes to -390, it will be right before here. So we're going to keep it from either going off on either of the x ways. So if the ball, its position is greater than 390, we have to make it now go backwards. So we're going to reset its speed. By doing something like this. Ball.dy equals the current ball.dy. So however fast it's going, if it's going, oh, I'm sorry, dx. Ball.dx is going to equal ball.dx times -1. So if I was going a speed of 2 in the right direction, I'm now going to make it go 2 times -1, which will switch the sign, and now it's going to make it go -2. And let me copy this. And you'll see this in just a second. Hopefully make more sense. You see it running. But now this is saying if the x position is less than 390, like you're falling off the screen on the other way, we're going to reverse the sign. That's what this means. Reverse the speed. So now let me change the speed back to, let me just make it 1. And you know what? I'm going to make the x 0 for now. I just want to move left and right. Let's save this. And run. Cool. Sweet. Okay, so I think... Oh, you can't even see it. I'm sorry. Like saying, sweet, it's working. It's off the screen. So now we can see this code going. This is the border checking code. In this loop, forever and ever and ever, it finds out where the ball is and updates it a little bit, which gives it the appearance of moving. So it adds a little bit x, and then redoes it. A little bit of x, redoes it. So it always looks like it's moving 2 pixels per readjustment. Or 1, whatever I set it as. Now, I used an if statement. I said if the ball's x position ever gets to be greater than 390, so right then, it then makes the speed switch signs. So now instead of adding 1 and adding 1 and adding 1, as soon as it hits the wall, it subtracts 1, subtracts 1, subtracts 1. Now it adds 1, adds 1, adds 1, adds 1, adds 1. Now it subtracts 1, subtracts 1, subtracts 1. And now it adds 1, it adds 1, it adds 1. That way we can kind of always keep it in bounds. Alright, so in the next video, we'll learn how to kind of close off the Y ceiling and the Y floor. It's going to be very similar. And then later on, we're actually going to find out how to also make it check if it's hitting a paddle. I guess that's called collision detecting. Alrighty, I will see us soon. I hope you guys are enjoying this. This has actually been pretty fun to make. I feel like you guys are probably getting really sick of my voice. And if you made it this far, congratulations. No, I'm just joking. Alrighty, I'm stopping it for now. See ya.